Lesson 7-8, we're going to look at volume of rectangular prisms. Starts on 435, and you're not going to be given a formula. You're going to have to memorize this formula for volume of rectangular prisms. So in the past with the ISTEP, there was a reference sheet that was given to you, and they actually gave you the formula for the volume of a rectangular prism. Like I said, this will not be given to you. It's a fairly simple formula though. We're multiplying the length times the width times the height. And you guys actually did this last year. Okay? Volume of rectangular prism. Length times width times height. So you multiply, and that's it. This formula is not given in your books. So if you're interested in that, you can write that down. So if we look at example 1, they're asking what the volume of this rectangular prism is. The first thing we're going to do, we could start out with our formula. So similar to, you guys know the area of a rectangle is length times width. The volume of a prism, which is kind of like how much could fit inside of a box, is kind of what we're talking about, is just length times width times height. So we're just adding one more dimension. So it's kind of like, you know, what's the area of the base of this thing, and then multiply by its height tells you the volume. And with volume, our units are going to be cubic units, because it's kind of like how many cubes could we fit inside of this thing. Okay, versus area and surface area we've done have been square units, because it's like how many squares could be like along the outside of a figure if we're talking about surface area. So for this problem, if we start with our formula, we're going to do length times width times height. And our sides, our length is 2.5, our width is 2.5, our height is 1.5. So we could change those to improper fractions. 2.5 is the same as 5 halves. 1.5 is the same as 3 halves. And then if you multiply straight across, 5 times 5 is 25. 25 times 3 is 75. 2 times 2 is 4. 4 times 2 is 8. So we have 75 eighths. And then that gets us where the book has us here. 75 eighths, you can divide that out. If you take 75 divided by 8, and you'll get 9 3/8. Okay? For this problem, if you were allowed to use a calculator, technically the 2.5 you could put as 2.5. The 1.5 you could put as 1.5. And if you work that out, you would get 9.375. Okay, so it's going to just depend on, again, sometimes we're allowed to use calculators and sometimes we're not. For some of these, I think it would be good practice if they give you some fraction problems that we work out some problems actually working it out by hand. Okay, because otherwise we're going to get out of practice and forget how to do these problems. We're just going to be so used to always using a calculator. So if we look at the try it, they want us to find the volume of rectangular prism built from 1/2 inch cubes. So we can just look at our picture here. Just like we did on the last problem, we can do length times width times height. Our length here, you might say is 2.5. Width is 1.5. Height is 1.5. Length is just usually considered to be the bigger dimension on your base. Okay? If you mix them around, obviously we're just multiplying these 3 dimensions. And I could turn this different directions, and then my height would be different, right? So there's not really a wrong way of doing this. we're just going to multiply and get our answers. So again, technically very similar to what we did up above. 2 times 2 is 4, plus the 1 on top makes that 5 halves. 1 times 2 is 2, plus the 1 on top is 3 halves. And then we've got another 3 halves. And we can multiply those. 5 times 3 is 15. 15 times 3 is 45. 2 times 2 is 4. 4 times 2 is 8. So we've got 45 eighths. And 45 eighths. 8 goes into 45. 5 times. And we have 5 left over. So that'd be 5 and 5/8 cubic inches. A way to help you remember your units is we multiplied inches by inches by inches. So when you multiply the same thing by itself 3 times, you're cubing something. Just like 5 times 5 times 5, that's the same as 5 cubed. Okay, 5 to the 3rd power, 5 cubed. If you are allowed to use your calculator for this, again, you could put 2.5 times 1.5 times 1.5. And if you do that, just to mention a feature that's available on your calculator, is if you hit the second button, once you get your answer, second button, and then this PRB button. Second means we're looking at the secondary feature of the button, which is above the button, which allows us to have half as many buttons as we would have to have otherwise. If you look above there, there's an F and a D and 2 arrows between it. That's standing for fraction to decimal. Okay, so if you were doing this problem, again, you could do 2.5 times 1.5 times 1.5 if you were allowed to use a calculator. And you would get, what, 5.625? If you get that answer, 5.625, 5 and 625 thousandths, and if they don't want you to give a decimal answer, that's where you could use that function on your calculator. You do second and that PRB button, and that will change that to a mixed number. And it'll look like this. There's kind of a little bracket, kind of a sideways bracket there, and that's kind of separates the whole number from the fraction part. Okay, so just to show you what that looks like if you're allowed to use that, or even if just for your homework, maybe you did a problem by hand and you want to check your answer and make sure you did it correctly. Example 2, Sean bought the fish tank shown. What is the volume of Sean's fish tank? And they do actually show you the formula here, so it is actually in your book. All right. So length, width, and height, substitute in, change to improper fractions, multiply straight across is 40/9. And then if you divide that out, again, as 40 divided by 9, you'll get 4 4/9 cubic feet. And this is an example. This is part of the reason why I don't want you guys changing to decimals, because on this problem, 1/3 is a repeating decimal. So you're not really going to be able to nicely put that in your calculator. 0.3333333 on forever. Okay? So just stick with the fractions and you should be in good shape there. Example 3. We have a ring box in the shape of a cube. What's the volume of the ring box? So there's the dimensions. This is a cube, so the book's saying, oh, our length, width, and height are all the same, so we can just cube that side length. That's fine. Or you can do length times width times height, like we've done on all the other problems. Okay, so 2.5 times 2.5 times 2.5. And if you'll notice, we're doing the same exact thing as the book here. So don't worry, what I'm what I'm saying basically, we don't have to worry about finding a new way of doing this problem. Just because it's a cube, the length, width, and height happen to be all the same, that doesn't mean we have to do the problem any different than any other problem. Okay? If we look at the try it part A, we have the first problem that has decimals in it, doesn't have fractions. If you're given a problem with decimals in it and you're trying to find the volume, just to speed things up a little bit, you can just use a calculator to multiply those out. So 3 2/10, 2 8/10. Our height is 4 5/10. You can just multiply those on the calculator. On the calculators you have, you can technically type all of that at once and then hit enter. If you'd like to, you can multiply 2 of the numbers, get your answer, and then multiply and get the next answer, which is what on some calculators you would kind of have to do anyway. Again, the nice thing, these calculators, it'll show you exactly what all you typed in, and then you can make sure you typed it correctly. So if you multiply those, that would be 40 32/100 cubic centimeters. All right, and we're not going to worry about changing that to a mixed number answer. You can just leave it like that. Part B, just going to mention briefly, is just one that happens to be a cube. So our length, width, and height are all the same. Okay. Since they're halves, you could put it as 4.5. Okay, just to get some practice, I'd like you to change it to improper fraction. Now, even though I'm having you work that part out by hand, the 9 times 9 times 9, you could use a calculator to multiply just to make it a little quicker. 2 times 2 times 2, I think you can handle. And then you can divide that out. You could divide it out by hand. If you wanted to double check yourself on the calculator, you could do that and use that fraction to decimal button we were talking about earlier. Anyway, that should end up as 91 1/8 cubic feet. On workbook page 107, number 12, Marita uses the pan for cornbread. There's 3/4 of an inch of space left at the top of the pan when her cornbread is done baking. What is the volume of the cornbread Marita made? So on this problem, basically one way of looking at this is that we have some space at the top. So even though this pan is actually 2 1/4 inches, we're going to imagine our cornbread's not going all the way up. So the question is, where does it go up to? Well, 2 1/4 minus 3/4. It tells you it's 3/4 of an inch away. So you could borrow. That'd be 1 2/4 or 1 1/2. So we've actually got our cornbread only going up 1 1/2 inches. So 8 1/2, 8 1/2, and 1 1/2. So that's 17 halves, 17 halves, and 3 halves. When you work that out, if you multiply all those, you should get 867 over 8. If you divide that, change it to a mixed number, is 108 3/8 cubic inches.